Oi, what's good, YouTube? This is a fun and a long one today. Anthropocentric bias and the possibility of artificial cognition. I not only have this paper, I also have running through a rough draft of one that I wrote a while ago. You're going to want to watch this video, right? What we're going to do here today is talk about what exactly understanding means, what it is to understand, and do AI models understand. I am going to be very contrary to probably what you think and what definitely what most machine learning researchers think. I'm going to argue that these models in certain scenarios in certain ways, and I will very strictly define this, I'm going to argue that they do understand. First, though, I'm going to get to this paper. This paper by these two authors is a more general look at what it means to have anthropomorphism or anthropocentric bias and what that means for the way we approach AI. And only after this paper, I'm going to get into the actual one that I wrote a little bit. And then we will also touch on a comment someone left me on YouTube as well. But, anyways, yeah, hope y'all enjoy. Let's get to it. So, the question of what cognitive competencies do language models have? Truth is, we do not have any kind of framework to answer this. People have very strong opinions one way or the other. Most people who you ask in the field will say they're not understanding anything, they're just stochastic parrots, but we really have no actual strict definitions that you would kind of need to make these claims at all, right? So if we just go around and kind of naively implement lessons and methods and tactics from experimental psychology, that kind of risks succumbing to both anthropomorphic and anthropocentric biases. Anthropomorphic bias involves attributing human qualities to LLMs without justification, whereas anthropocentric bias, though more challenging to articulate, roughly entails evaluating LLMs according to human standards without adequate justification for applying those standards and refusing to acknowledge the possibility of genuine cognitive competence that differs in substantive ways from our own. This is that question of the not actually an Einstein quote, but it's called an Einstein quote all the time, where he says, if you judge a fish by its ability to climb trees, you will forever think that the fish is stupid. There's a certain question here when we are judging these AIs off of question answering multiple choice benchmarks, we're really probably underestimating their true intelligence, their true ability, which is this future prediction engine, given that it's next token prediction, at least for LLMs, right? So we're going to dive into these questions here today. Now, they're going to define competence as the system's internal knowledge underlying a particular capacity and performance as the observable behavior of a system exercising that capacity. Now, the difference between these two terms, right? Here's the example. A student cheating on a test demonstrates performance success without competence, while a knowledgeable student failing due to anxiety shows performance failure despite competence. These examples might invite criticism that applying the performance competence distinction to LLMs is inherently anthropomorphic, since it relies on a concept of knowledge that properly applies only to humans. But personally, I think that very criticism is itself anthropocentric, but whatever. We can avoid that concern by providing an alternative formulation of the distinction. In an experimental context, performance refers to how closely a system's behavior aligns with some normative standard of success on a task, while competence refers to the system's computational capacity to meet that normative standard under ideal conditions. So we're just asking, how well does the model actually perform on the benchmark in the given setup you have for the benchmark? And how well does the model, or could the model perform if we had ideal conditions, let's say, for example, an ideal prompt, right? The authors suspect that within the ML research community, anthropocentric bias is motivated by the reasonable desire to temper the opposite and perhaps more irresponsible form of bias, anthropomorphism. Fighting one bias by entrenching another will not foster impartiality. That's the point they're making. Now, me personally, I would argue that sorry, I'm getting confused. I would argue anthropocentric bias is possibly just as uh, dangerous as anthropomorphism, maybe even more so. But I believe that comes from my differences in my opinion of how consciousness is and what it works. We will get into that in the later paper, the one that I half wrote. This is an interesting point here. Every mechanistic explanation highlights some causal factors and relegates others to the inventory of enabling conditions that we tend to ignore on the basis of the assumption that they will remain stable. For example, when we look for causes of a forest fire, we cite the discarded cigarette and ignore the presence of oxygen. Sometimes, however, our assumptions about the enabling conditions are wrong. So this idea of causality that we have, it's very contextual. We tend to really focus on some causes and totally ignore most of them under the idea that they're just constant, they wouldn't change. There's this element of change over time that is kind of necessary for us to equate causality. However, it might be interesting to wonder or to think about how we may be running into issues with our definition of causality when we wrongly measure, wrongly think about, wrongly contextualize those usually constant factors. In the case of that was the case of like a over time causation. In the case of like testing an LLM, for example, we may just not understand very well those constants, those underlying assumptions. We might assume that some enabling mechanism is present in the target system merely because it is present in humans. If the target system lacks that enabling mechanism, it might fail for reasons unrelated to the competence of interest. In the mirror test for self recognition, for example, we put a red mark on the animal's body and then observe whether it tries to remove the mark in the presence of a mirror. The experimental design assumes that other animals care for the fact that they have a red dot on their body. If that enabling mechanism is absent, they will fail the self recognition test for reasons that have little or nothing to do with self recognition. This is interesting. So we have this psychology, or I guess animal behavior psychology, whatever test, where you put a red dot on their forehead or chest or something, and the idea is they want to test to see if they're actually self-aware and if they comprehend that the mirror, the animal in the mirror is them, right? But the test only makes sense with a bunch of assumptions like we assume the animal cares about the red dot. We assume the animal can even see the color spectrum red, isn't colorblind or something, right? There are so many assumptions in there where we might falsely conclude the animal either is not self-aware or just more strictly does not have the capacity to recognize itself in a mirror based off one of those other factors that are messing with the data, even though they actually might have said self-awareness, right? Neglecting this effect of auxiliary task demands on model performance can lead to inferences about competence astray. So because of this stuff, we could actually mess up our inferences about how competent, how smart they are. Such negligence is compounded in comparative studies with mismatched experimental conditions, resulting in divergent auxiliary task demands for LLMs and human subjects. A lot of time we're comparing humans to LLMs, and there are a bunch of differences in the way that the task is presented to or performed by the LLM versus the human that are potentially messing with our results. This concern is highlighted by some prior studies where they compared human and model performance on recursively nested grammatical structures in response to some prior study. That prior study found that humans outperformed language models on challenging long distance subject verb agreement dependencies in embedded clauses. However, the newer study notes that human subjects were given substantial instructions, training, and feedback to orient them to the experimental task, while models were evaluated zero shot without any task specific context. The discrepancy in experimental conditions confounds the comparison. The additional context provided to humans but not models can be interpreted as imposing weaker auxiliary task demands on humans than models. So the issue here was something along the lines of like you read a sentence and at the end it says him or her or they, and it asks you what is that last word referring to, him or her or they. Is it the first person in the sentence that was mentioned, the second person, right? I think that's probably a more simple version, but it's like they're testing out that idea, that little part of language that like, humans can usually do. And the point being made here is that in those studies, they claimed that the models couldn't do this task, could not identify the subject or object, which one was being referred to by they. Whereas what was happening is in the human test of whether humans could do it, they were describing the task to the human in depth, answering any questions, showing a few examples, letting them sit down and think about it, going, giving them time to think through their answer, right? Whereas with a model, They just kind of gave it the sentence, said, and then the next sentence said, "Who is they referring to?" Which is so the model got way less preparation and context as to what they're going to be doing than the human did. To level the playing field, the newer study tested LLMs on the same task by providing it with prompts containing a few examples intended to match the orienting context given to human subjects. With this modest task specific context, LLMs perform as well as or better than humans, even on challenging sentences with deeper nesting than those tested in humans. So this older study thought LLMs just couldn't do it. The newer study found when you accounted for this stuff, the LLMs were actually as good as or better than humans. Tasks that are considered trivial for humans may not be trivial for an LLM. The classification of a task as trivial depends on the causal structure of the system being tested. This is interesting. So some things for LLMs are really easy. Humans, if you were to ask them to, you could give them a sentence or a paragraph or something and tell them predict the next word most likely. I have a feeling at this point the LLMs will be better at that. Humans are not going to be very good if you check their success rate at actually predicting the next word. And then this idea of what task is trivial to a human versus an LLM is not entirely clear. It really depends on that causal structure, all of those context clues and those things being held constant, and how you view the system. One of those kinds of auxiliary factors that are messing with stuff is what we call input dependent computational limitations. So there is converging evidence that the expressive power of transformer-based models, their ability to actually perform well, can be constrained by the number of tokens generated before producing an answer. This was I found this, it was in a paper, I want to say last fall. I forget what it was called, but it was talking about pause tokens. I believe that was in the title too, where basically what they did is they said, wait a minute, when a human has to answer a question, the human's allowed to sit there and think for half a second, 10 seconds, a minute, who knows, right? Whereas with an LLM, the very structure of the math is such that it is forced to give an immediate answer in like the very next step immediately, right? Just with the next token. And that kind of probably makes them worse and makes them dumber than they could be potentially. And what this paper did was they introduced this thing called pause tokens, where they allowed the LLM to not give an immediate answer, but instead keep generating a couple tokens and eventually finally give an answer. And I believe they were doing a set number of them because it's hard to like figure out how to train this thing and how many of them to use. But the reason this matters is because the actual math structure of the transformer, the actual matrices and the tensors, right? That increased width, aka that you get from more tokens in the actual sequence, width, uh, allows for actual more computations to be done. There's more computational space to happen in there, right? And what they found was when you let it pause for a little bit and like output some pause tokens that are meaningless and just give it some more time, some more token steps, they actually had better performance out of that, which was a crazy finding, and has since been taken advantage of in a couple attempted papers to get more out of this. I think one of the big ones that was like getting everyone's attention was called Quiet Star, maybe. I want to say it was Quiet Star. And then another kind of auxiliary factor that messes with all this stuff is what we might call mechanistic inference, according to which a network learns a mechanism for solving a certain kind of problem, so it does learn it, but the activity of that mechanism is interrupted by another conceptually distinct process. The big example we found so far is a Neil Nanda paper where they showed that even after a transformer did create within its weights a generalizable like computational circuit that could implement the algorithm to solve modular addition, so it was like a simple math problem. Eventually, after enough training, the model did actually figure out a correct internal algorithm to solve it. It still wasn't able to perform perfectly at first, anyways, where its test set performance was still impeded by previously memorized input output mappings until a later cleanup phase in which this rote memorization was removed. So what happens in that paper, the grokking one, basically what they found was internally the model actually did understand, did have a proper circuit to solve the problem, but before it found that circuit, what it had been doing was memorizing just individual question answer pairs. It had been memorizing those to try and memorize the data set before it actually learned the pattern what was happening. And what happened was, even once it learned the correct generalizable circuit, it still took a while for it to shake off those memorized question answer sets that it had from earlier, and they were messing with its performance. The way these models mechanistically work is such a way that different parts of them can interfere with other parts and ruin our impression of how smart they actually are in terms of what is the actual capabilities internally of the algorithms they have developed, right? So those were all examples of what we call type 1 anthropocentrism. Type 2 anthropocentrism is the tendency to assume that even when LLMs achieve performance equal to or better than the average human, any substantive difference between the human strategy for solving the problem and the LLM strategy for solving the problem is ipso facto evidence that the LLM solution is not general. All right, so type 1 was just saying, hey, sometimes we are underestimating their abilities because there's something getting in the way of their performance. Type 2 is when humans say, hey, even though it's performing well and it's having success on the metric of interest, we are going to just cross our arms, get all mad, and say, well, it doesn't solve it the way I would solve it, and I understand, therefore it doesn't understand, which is so silly because when you think about it, think just back to like third, fourth, whatever grade math, right? Remember, they gave you different strategies to solve multiplication, addition, times tables, whatever, right? There are multiple different strategies to do so. And just because you prefer one strategy over the other, and I prefer one strategy over the other, does not mean that you understand and I don't because I use a different strategy algorithm than you. We can use different algorithms and both still understand the same underlying concept. So when humans look at an LLM, that is this is actually like the central point of my paper that we'll talk about next. When humans look at an LLM and they see that it does perform well, that it's not just performing well on the what it saw memorization wise, but that it actually is capable of answering correctly any question that it had never seen before. It's generalizing. When humans don't grant it understanding, even though it can do that, we are being anthropocentric and we are unreasonably requiring that it do things the way that we do them, which is crazy because even among different humans, we understand things differently. We use different algorithms for our multiplication tables or whatever it is, right? So it's just very, very silly. This is the kind that just makes me very mad when I see people doing it. I so commonly will make a side note in my videos about how like, oh, the model understands this, yada yada yada, and I'll get a rant in the comments of like, these models do not understand. You're using that word incorrectly. Nah, I'm not. If you're ranting me about that, I bet you just have not fully thought this issue through as well as I have, and you're, in my opinion, anyways, is that you're making the exact same mistake that was being made by most of Europe when they insisted the sun revolved around the Earth and not the other way around, despite 100 years pre-Galileo of proof that it was the Earth around the sun. And the same thing with intelligent design versus evolution. There's this pattern in the progression of science over time where we consistently get humbled. We consistently learn that we are not all that, that we are not the center of the universe. And I think right now, what we're going to have over the next 5 years is a lot of people really insisting that if it's not a human, it's not real. If it's not a human, it doesn't understand. If it's not a human, it's not conscious. We're going to really be over the next 5, 10, 15, whatever years forced to face this issue in the same way that we once faced the sun around the earth issue and the and all that stuff, right? And we do want to clarify with this point an LLM to we want to clarify between memorization versus generalization. An LLM that relies on a giant lookup table of memorized addition problems would not be competent at addition because it could not flexibly apply its memorized content specific transitions to novel cases. But a neural network that learns a general addition algorithm could be seen as competent in the domain, even if the solution it has converged upon is distinctly unhuman-like. So this is a huge issue with you know, John Searle's Chinese box or thought experiment, we'll discuss that when we do my paper later. But this is a big thing that I clarify in my paper to a much deeper extent. So you might be objecting, this is one reasonable objection, since the only indisputable examples of language-driven cognition we have are human, and since the capacities of LLMs are acquired through training on human-produced data, isn't it appropriate to treat human cognition as the only appropriate yardstick for studying LLMs? Our response is that it depends on how we conceive of human cognition as a yardstick. While we can and presumably must begin our investigation of LLM competencies by comparing them to our own, the role of human cognition as a benchmark can be overstated in two ways. First, human competencies we use as a reference points should be regarded as what philosopher Ali Boyle calls investigative kinds. They serve as an initial search template, but not as necessary conditions for cognitive status. Second, questions of the form, do LLMs have cognitive competence C, or like just some given competence, should be treated as empirical questions, not as a why I feel like they do or don't, right? And the paper does want to point out as a conclusion, anthropocentrism being more subtle than anthropomorphism has garnered less theoretical scrutiny. This is a big thing that I was thinking months ago when I wrote my paper, is people are just really focused on anthropomorphizing the models, like, oh, don't pretend it has feelings, it doesn't understand, but like you're really underestimating the issues and dangers that we might face with anthropocentrism. Fundamentally, actually, we'll get into it. All right, now for my paper, my draft. It's more notes than it is actual draft, if anything. My notes, right? This was written last fall, I want to say. Please ignore the emails. Do not email us just for no reason. On stochastic parrots and anthropocentric bias, strictly defining what it means to understand. Related to this, I also have a video that I will link in the description, or probably have at the end credits video too, where I go past just understanding and also talk about general self-awareness and consciousness in these definitions. But here today we're going to do just like understanding and what it means to understand for a model, right? Let's get this abstract. This paper explores the contested issue of whether artificial neural networks can be said to understand in a meaningful way. We take inspiration from recent insight gained by research into the grokking phenomenon, or more specifically, the efficient internal representations capable of generalizing to unseen data that it sheds light on as a suitable, I don't know what word to use here, I want to say teleological definition for comprehension. Drawing on recent work that provides a theoretical explanation for grokking by delineating between the emergence of categorically different computational circuits, the paper argues for a new standard for understanding rooted in a model's ability to generalize rather than merely memorize. Furthermore, this framework can be utilized to explain but not predict emergent abilities that arise abruptly despite a smooth decrease in loss, and proposes a novel methodology for designing trained test datasets that would, in theory, allow for understanding to be quantified empirically. This framework is further used to challenge the anthropocentric biases, which assume that non human forms of intelligence must mirror human cognition to be deemed as understanding. We conclude by arguing that any alternative definitions of understanding are either dualistic or unfeasibly strict. Thus, we establish computational comprehension as a superior metric for evaluating the cognitive capabilities of language models, thereby offering a more philosophically robust and practically applicable standard. We will get into this in a second. If you want to read through these notes slash very, very rough draft, again, it's on my GitHub. If you want to help me out on it, I'm not going to do any more work other than maybe answering questions. But if someone's like, if you're a philosophy, computer science, dual major, and want to do a senior thesis or something, please take this and go ahead. Let's get into it. So I want to emphasize here again, historically, science has progressively worked to strip away these anthropocentric biases. A pivotal moment in its evolution was marked by the collaborative contributions of Nicholas Copernicus and Galileo Galilei towards the heliocentric model solar system. So I mentioned this earlier, the whole like, we really had to come to terms with our own smallness and our wrong assumptions by default that we were just assumed to be the center of the universe, right? And that this is an actual historical pattern in the sciences of us repeatedly seeing this to be the case in any field, any domain. We repeatedly find ourselves to not be the center, despite what our, at least in the Western culture, traditionally has us assume about ourselves. Now, the forefront, at least to my knowledge, philosophical example thought problem on this is the Chinese room paradox. And to really get to tease at this, we have to draw the distinction between simulating understanding and actual comprehension. Philosophers who argue against the possibility of AI understanding often point to the lack of conscious experience, intentionality, and subjective understanding in machines. So John Searle, I'm not sure, created this Chinese room paradox example. This thought experiment challenges the notion that a computer running a program can be said to understand a language. Searle imagines a scenario where a person who does not speak Chinese is locked in a room with a set of rules in English for manipulating Chinese symbols. The person can produce correct responses to Chinese characters slipped under the door by following these rules, thereby simulating an understanding of Chinese. However, Searle argues that despite the convincing output, the person does not understand Chinese. So they're saying, like, imagine this person in a room who speaks only English had a book that's just an, I guess, a library full of just, if these Chinese characters come in, send out these other Chinese characters, right? And Searle's argument is that that's what computers are doing and that they are not understanding. He extrapolates this to assert that similarly, computers can simulate understanding without actually comprehending. The Chinese room paradox implies that syntax alone is insufficient for semantics, suggesting that AI, which is presumed to operate on syntactic manipulation, lacks true understanding. This argument has sparked considerable debate and criticism. Critics argue that the thought experiment is flawed in its anthropocentric view, suggesting that the understanding might not necessarily manifest in the same way in machines as in humans. Additionally, some argue that the whole system, the person, room, and rules together, could be said to understand Chinese, challenging Searle's conclusion that the understanding is strictly a human attribute. I love that criticism. Uh, Most notably, I would say, yes, the person doesn't understand. Yes, even the book doesn't understand, but the person who wrote the book understood. Does that make sense? That book of Chinese and inputs and outputs of what to respond to a given Chinese question or whatever does not come from nowhere. That person who wrote the book or people, they understood Chinese. And so you are looking at the wrong part of the system. It's almost like you were to say, "Oh well, Evan, your mouth outputs English, but your mouth isn't your brain. Your mouth doesn't understand." Well, yeah, duh, but my brain told my mouth what to do. Similarly, the person who wrote the book gave the book to the person who's in the room. Like the fundamentally, this Chinese room paradox really has the wrong sense of context for what is happening in this scenario, and is effectively straw manning the argument. So a big thing I pointed out in this next section is, I said, uh, we have seen so far, thanks to the subfield of mechanistic interpretability, that not only can we understand how these models work in some cases if we really dig deep enough, but in some, we've actually found that learning about the models can inform us about how our own brains work. Big example, I think I must have lost my citation in here, maybe LaTeX messed it up, but basically is the idea that uh, vision researchers at one point in their convolutional neural networks found these things they call curve detectors, that are, if I remember correctly, I think the fundamental units of making up shapes and things in these vision models, if I remember, and they're like an emergent property of, you train the CNN and it develops this specific algorithm, this curve detector, right? And it was later found by neuroscientists that the exact same, like, or similar structure, a curve detector, exists in the human brain, visual neural, whatever the heck, somewhere near the eye, I guess, or visual cortex as well. And that kind of shows you how, hey, wait a minute, we really should not be discounting these systems' forms of intelligence so heavily or so much if they, through entirely separate means of training, our brains get trained by, like, growing up in evolution, and theirs get trained by looking through data and backpropagation. If we can both still converge to the exact same type of algorithm and structure in our, like, very most fundamental systems, we really should not be discounting what exactly it is these AIs are doing in there. And so what I want to hope happens in the future here is that if mechinterp, the field, can uncover the underlying structures and processes that drive AI decision making, and neuroscience demonstrates that the brain executes similar algorithms in varying modalities and levels of abstraction, it might provide a more concrete basis for arguing that AI systems are capable of a form of understanding, albeit potentially different in characteristics from human cognition in many cases, but not all cases, as it's clear. This definition of understanding would be grounded not in human like consciousness or subjective experience, but in the distinct, intricate computational strategies that these models develop and refine, some of which may be similar to or shared with analogous biological circuitry. So, next, a little background if you haven't actually seen before or heard of grokking. In machine learning, if you're not already aware, we have two data sets usually to oversimplify things. We have a training data set, which is the biggest part of the data set, and then we have the test data set. Maybe 5 to 10% of what's available you allocate, put aside to your test data set. The same logic being like if your professor in school, your teacher, teaches you things and gives you a study guide, they are not going to give you the test questions ahead of time. Because if you did, you run the risk, or they run the risk of you having memorized them, right? We want to make sure you are not just memorizing your textbook and study guide word for word to actually understand. So the teacher purposely makes a test in which the questions are on the same concepts and using the same principles, but different from the study guide you saw, right? And what we do in AI is the same thing. Our training data set is our study guide, and our test data set is our final held out, you can't see it until test time test, right? What happens with grokking, this happens with some models or with any type of model, but under certain conditions. And we're not going to get into the conditions that allow it to happen or theories about how it might always be happening at a low scale, at a very small scale. But basically, when you have a data set that is only one single task, this phenomenon becomes visible, where the model will either learn healthily, aka it will get better at the test at the same rate it's getting good at the training data set, or it'll memorize, meaning it will get perfect at the training data set, but it will never learn anything, never get any accuracy on the test data set, or the grokking scenario, it will memorize the training data set. This is the curve on the right here, C, right? It'll memorize the training data set, but still have no ability on the held out test data until you just keep training it. Nothing seems to be happening. There are some actual things that are happening, but let's not worry about that right now. And eventually, all of a sudden, and it's not very sudden, this is in log scale, obviously, but eventually the model groks. It suddenly understands. That word grokking is a from some, I think, 1960s or 80s sci-fi book. It's a Martian word that means to understand deeply and I think suddenly. And basically the model will, despite nothing seeming having happened for a while, all of a sudden get better at this blue line, at this held out test data. And what happens once it has grokked is you can now show it any new question of the same type but that it has not seen before, and it will get the answer correct. Whereas before it grokked, you show it a new question of one that it hasn't seen before, and it can't do it because it has only memorized. The student who has the study guide memorized and but cannot do well in the test has not grokked. The student who suddenly has a eureka moment and like it all makes sense all of a sudden and they can now perform well in the test, that student has grokked, right? And then a paper, I believe, by Max Tegmark, if I remember correctly. I could be wrong about that though. There's a citation in here if you want to check it. A paper that I did a video on months ago at this point talks about how they analyzed the different two main circuits that are occurring in the model, circuits being like the actual algorithm within it. And what they found was that there is what they called circuit memorization, which is the part that is literally just memorizing every single data point it sees to the best of its ability. Then there is the generalization circuit. The first one is very big and complex because it takes a lot of effort and information processing to memorize every little data point. The second one, the generalization one, is very simple, streamlined, just a beautiful mathematical algorithm that keyword here, generalizes, is capable of performing well even on data points it has never seen before, right? So they actually found in these models that there's two different things happening, and you could kind of say that once the generalization circuit overpowers the memorization one, the model has grokked, right? And fundamentally, in this paper, I posit that we should define the word understanding as just on a given subject as just has the model grokked on that subject. The more technical term I propose, I call it uh, computational comprehension. If you want to reserve that word understanding for your feeling of understanding, I feel like I understand, you can keep that word if you want to. At the very least, give me computational comprehension. My kind of thing I want to posit in this paper is that we need to give the models more credit where credit is due, and we need to stop conflating our feeling of understanding, the way I feel having understood, to the actual neuron algorithm in my head that occurred while I was doing the task at hand, that algorithm is what did the actual understanding. Does that make sense? So I'm saying I am separating out this fundamental problem of consciousness, of sensation, of feeling from the actual algorithm that I am using in my head to do the task. And I'm saying that algorithm is what understands or has computational comprehension. You probably, if you're critiquing me right now, are probably not actually having a strict good definition of what you're saying. You are probably referring to the feeling of comprehension, how it feels, the whatever Greek philosopher called this qualia, the subjective experience, the the what it feels like to see the color red, right? What it feels like to understand. And so by that metric, I would say any model understands if it is capable of consistently with high accuracy answering questions that it has not seen in the training data set, then that means it understands that type of question. And like similarly to humans, right? You wouldn't say I understand uh, organic chemistry if I have never taken an orgo course before, right? But you would say I understand economics. I've taken a lot of economics classes and done very well in them. And even post my classes and post my tests, I have been able to succeed in an economics based job where I constantly had to test that knowledge, right? In this same way, we're doing a subject specific definition where I'm not saying that like ChatGPT understands everything. Certainly, I think a lot of the stuff it is doing is very obviously out of memorization. When you ask it to like, you can get it to like show that it has memorized an entire New York Times article, right? I'm not saying it understands in that case. It does seem like it's memorizing. I am saying that with tasks where it actually can generalize to just unseen examples, it is having computational comprehension by my definition. And so when we get back to this Chinese room paradox, right? What I'm claiming is certainly the the person in the room with the huge book or library of Chinese phrases, input, output, answers, right? Certainly that person does not understand. And that book itself is reflective of understanding, but the understanding fundamentally comes from whoever wrote that book. And it is unfair to posit this room thought experiment paradox without clarifying who wrote the book. The person who wrote the book in the system is the one who understands. Now, that is assuming that the person who wrote the book does have a simple generalizable memori like a generalizable circuit, right? Somewhere in their head. If they don't, then we're going back a level. You might say, based on this interpretation, that oh, the actual understanding is in the training data set of the LLM, that it comes from the humans, and that the LLM is just memorizing. Well, kinda. In cases where it actually is, like the book, just memorizing phrases, yes. But we have seen there's plenty of cases where these LLMs can, honest to God, respond to new combinations of tasks put together in things and just new examples of tasks that were not in their distribution. I think to whatever degree that a language model response has actually not been found on the internet somewhere, we should say that that is, and that it gets it right as well. I want to clarify that it gets it correct. We should say that is understanding. And also very dependent. My definition is very dependent on the idea of what we found with that memorize or that generalization circuit is that it's, to be clear, this generalization circuit is as low dimensional as possible or relatively low dimensional, meaning simple. So memorization is an inherently complex high dimensional task. It requires that you basically use every single degree of freedom you have, whereas understanding, comprehension, generalization to unseen data necessarily, we know from this from grokking stuff, involves low dimensional representations, as low as the actual dimensionality of the problem, right? Next point to point out, I wanted to say just also keep in mind it is totally possible to understand or know something without being conscious of it, without feeling it. Likewise, it's possible to be conscious of something without understanding it, right? So when people are out here arguing with me saying like, "Oh, humans understand, the AIs don't," I feel like I understand. Your feeling means nothing to me in relation to the word understanding. Now, I do acknowledge that you feel that you are like a conscious being with a subjective experience, yes, but you are falsely equating the word understanding, that concept, like to understand something, with your feeling of what it feels like to understand. And it is totally possible to know or understand something without being conscious of it any given moment when you're not thinking about a given thing that you do know in your head somewhere. You're not feeling it by definition, but like I would still say you understand it because that algorithm is still somewhere there dormant in your head, and I could bring it up by reminding you of that given type of math problem, right? Likewise, uh, you can be conscious of something, you can feel a phenomenon without understanding it, right? Just because you feel something doesn't mean you understand it. We need to stop falsely conflating our subjective sense of being conscious with this idea of understanding. And once you stop doing that, it becomes very clear that it is possible for an AI model to understand something, and that the debate of consciousness is a wholly separate debate that we can get into a different time. You see what I'm saying? Now that we have this definition, this lets us get a simple little table to say, all right, what is an accurate claim? What is an inaccurate claim? When it's inaccurate, what kind of bias are we displaying, right? So up top we have two options. The model has grokked. The model has developed a low dimensional internal circuit that generalizes to unseen problems of the same task type, and model has not grokked. Model has not done that. Model is still working entirely off of memorization of data that it has seen, right? Then on the left, we have human claiming the model understands and a human claiming the model does not understand, right? If the model has grokked and the human claims the model does understand, that is an accurate claim by our definition of understanding of computational comprehension, right? If the model has not grokked and the human claims the model does not understand, that is also an accurate claim by our definition. If the model uh, has not grokked and the human claims the model understands that task, that would be anthropomorphizing the model, falsely attributing human like qualities or intelligent qualities or more qualities than it actually has to the model, right? Whereas if the model has grokked and the human claims the model does not understand, that is anthropocentric bias against the model. If that model can fully answer any question of that given task type that it has never seen before in training, and you want to claim it doesn't understand the problem despite being able to perfectly carry out perform the problem, you're crazy. You are just consumed with or you are consumed with anthropocentric bias, is my opinion. I want to point out one thing here. You may have noticed that by my definition, any random Python code could be claimed to computationally comprehend the task. Yeah, yes, I know. I am fully in on that. Don't get me wrong. Like my definition of call it computational comprehension, does require a lot of rephrasing of the issue. But fundamentally, I think it is a more legitimate definition, and I think it is very important that it's more usable. It is more accurate in terms of these types of biases. It is more strictly definable. It is will help us in future endeavors and benchmarking and shedding light on all this stuff. And it is important to point out that we need to pull back on this sense of this consciousness, this subjective awareness that we have, and like affiliating every little thing with that subjective awareness. We are so many of us are constantly falsely affiliating the feeling of doing something with the actual doing something. Our own self-awareness, like sense of experience with the actual thing. You see what I'm saying? Um, that's about it in this paper. There were things promised in the abstract you may have heard earlier that I did not pull through on just now or even written in here. I at one time had ideas for them. I skipped over a lot of bullet points and notes in this paper. If you want to go read it, there are many more notes in here. And I have like a whole huge section that is just like a huge literature review of grokking and anthropomorphism papers, like a ton of them. Feel free to read through and use this. If you want to work on it, let me know. I would really appreciate it. And I would be willing to help you out in terms of like an advisory role on it. But it's personally not a paper that I am prioritizing for myself right now. I would love to, if you want to get into this, read your edits and or read your changes. And I'd love to like critique and edit and like give you the primary authorship on this thing. Even just take it away from me, right? Go ahead. That is it for this paper. And then last but not least, I think we are going to hit on a YouTube comment right here that this is one someone left very recently in a recent video. I copy and pasted it to keep them anonymous because I know people don't like being called out or whatever. This person said, they're referring to me, you are understanding. The algorithm does not understand anything. Addition does not understand. You have it completely backwards. Again, my claim is that they are referring to the feeling of carrying out an algorithm. They are referring to the feeling of understanding and that they have not thought well enough about their strict definitions. Not gonna lie, I have not read these next four paragraphs. I have not read them at all. So we'll see if my mind has changed right now. When someone thinks they understand something, it is a feeling. It is a feeling that one gets when they can properly apply the algorithm slash formula to get the right expected answers. It is a feeling of accomplishment. That feeling of accomplishment lets one know they are doing it right. Understanding is completely nothing but feeling with awareness of what was to be understood. I actually love this, most of it anyways. Yeah, they are properly separating the feeling from the algorithm, right? And you know, my weird definition is I am qualifying the algorithm as doing the actual understanding. I would nitpick here. They're saying that feeling of accomplishment lets one know they're doing it right. Hear me out. You can have the feeling of accomplishment and the feeling of understanding, the subjective sense of I feel like I've got this, without actually understanding it. That is very common, and that is a crucial flaw in this worldview, in this view of the issue. Is if you feel like you understand the thing, but your teacher gives you your test back and you got an F, I've got a feeling you didn't actually understand it. And that's why I prefer to take that understanding word and give it to the algorithm rather than give it to your feeling. Your feeling, it's just the feeling of understanding, the sense that I understand. It's your own subjective internal self experience, right? I really think it's wrong in terms of the way that we use the word in most senses of the word understand. I think the way we usually use it should go with my definition and generally does go with my definition. And that people, when they get in this topic of like LLMs and do they feel things, they get all of a sudden blind to the way that they have actually been using the word understanding in a sentence their entire life. In your entire life, you've been aware of the fact like, oh, even if I felt like I understood the issue at hand, the task, if the teacher gives me back the test and I got it all wrong, I must not have understood. See what I'm saying? Algorithms do not understand anything. Algorithms are just processes that are created to get the specific results someone that creates them wants. They are simply functions. I would argue the thing you are doing in your head that you are feeling is itself an algorithm. You are feeling the carrying out of that algorithm the same way you feel senses of touch and taste and you see that you feel like on your eyeballs the color red or whatever, right? You are anthropomorphizing algorithms. They have no feeling. Only when AI becomes our very complex system on the complexity of a biological creature will they start to feel anything. I hate this take. I hate people who go into biology as the answer or sufficiently large complexity is the answer. Because here's the thing: if your metric is, oh, it has to get big enough, I know what you're doing. You're gonna keep pulling back the level of bigness it has to be as the models get better and better. You're gonna keep moving the goalposts. I don't trust you with this, right? And the biology thing, people insist on like they're not doing this here, but like a lot of people will insist that it has to fundamentally be biology for it to be conscious or smart or understanding or whatever. If you see someone making the biology claim, ask them like, why the heck is it that carbon is conscious and silicon is not? Why is carbon, what intrinsic trait of carbon allows it to be conscious or to have feeling or subjective experience or intelligence or whatever that silicon doesn't have? There is none. This person here isn't making that claim at all, but some people try and claim there's a hard stop between um, a silicon versus biological life, like silicon chips versus biological life. There is no hard stop in terms of how they process information and how they fundamentally act. You better show me a quantum process that silicon cannot do and that carbon can do, and you better then show me some crazy ass reason I can't imagine as to why suddenly quantum mechanics is definitely consciousness or something. This makes no sense, right? But they weren't making that point. They were making the point of complexity levels of like largeness. Even then, this statement makes no sense because how many uh, neurons does a worm have? Now, how many neurons does GPT-4 have? Exactly. Like if you're making size complexity of the system claims, you've already lost, right? Basically, when they are punished for getting it wrong, they can possibly after wrong. Wait, what? Basically, when they are punished for getting it wrong, can they possibly after start to feel? Well, I would argue that like a negative gradient or whatever, whichever direction, like a bad, like a gradient away from the answer you gave, that the model gave, is itself the punishment, the slap on a wrist. I don't see why you need to like have some sense of pain or dismay. Like you have to like I don't see in any way why the feeling of dismay, the subjective sensory feel like or the subjective feeling of dismay is somehow a prerequisite for the feeling of understanding. Like are all feelings built on each other? Is there a fundamental feeling to start with that you like a that a piece of life for like the first feeling it gets? This makes no sense to me. One might say that rewarding and punishing an algorithm creates such a feeling, but if it does, it is many orders smaller than what happens at the human level. The bigness thing is so weird. Like you're just going to assert like I mean, if you're just talking about parameter count numbers, like we're gonna hit there eventually, so this isn't gonna be a long-term debate or anything. But like again, the bigness thing makes no sense because I would agree, or no, sorry, I would argue that there is a thing that it is like to be a worm. I would argue there is some subjective sense of feeling that the worm has. Now it's probably very simple, very simple, but I would argue like there is a thing it is like to be a worm. To be fair, I'm crazy. Like I'm not. I'm like a you might restrict that to any information processing system, aka any life. However, anything that like acts against entropy. Personally, I'm suspicious that there is a feeling, a thing it is a thing for which it is like to be even a rock or an electron is my personal impression. But you as a person have to at some point draw the line of like, okay, at what boundary do I believe this thing has sentience, has a subjective experience of what it's like to be itself, right? And I have a graph here actually of it somewhere. So check this out. A debate in my Discord led to one of my subscribers drawing this out for me, right? This is a graph showing your level of confidence in that thing having a conscious experience, right? At the top of the bubble, top of the line is you. You're probably very confident that you are having a subjective sense of yourself, right? Now, Rene Descartes, cogito ergo sum guy, pointed out you can't actually be confident that other humans are conscious. You could be a brain in a vat. Like you don't know for a fact, you have no way of knowing, right? Most people, what they do is they extend out their confidence in that thing having conscious experience based off of how similar it is to yourself, how similar it is to themselves. So you might extend your sense of consciousness experience to all humans. I would argue for a long period of history, and even still today for most people are only capable of extending out that sense of conscious experience and having, and therefore having empathy for other people who are sufficiently close to them, whether that be like just themselves sometimes for like psychopaths, or one step out be people who like only care about their family, or further than that their friends, further than that their community, further than that their like country or race or whatever. I really do believe this is like a distinction that has like driven uh issues of racism and dehumanization over time, is this difficulty in extending your sense of sentience and sense self to other people. And then down the line, even further, you might extend the sense of conscious experience to like elephants and dolphins, the very smart animals. Maybe you do it to just mammals, like proximity to yourself. So like not even um, not even octopuses, just octopi, just mammals. Maybe you, and then again, like it's this proximity thing. So like mammals, so other humans are more similar to me than mammals are. Therefore, I am more confident that humans have a subjective sense of experience. Mammals are more similar to me than other animals are. Therefore, I'm more confident in mammals. Other animals are more similar to me than plants. Therefore, I'm more confident in those animals. Plants are more similar to me than rocks, therefore I'm more confident in plants, right? There's this sense of like distance from yourself in which people project out this confidence in the level of conscious experience that thing has. Most people don't get really past mammals, honestly, and oftentimes don't even get past their own kinship group or their racial group, right? Personally, I am pretty confident I'll go all the way to plants, and I am suspicious of rocks and electrons. I am highly suspicious that rocks and electrons, that there is a thing for which it is like to be that a rock or an electron, right? So that was, how do we get there? We were talking about this guy's comments and things. So he was talking about like size and like how big it must be, or they were talking about size, how big it must be for it to count. Personally, I don't like the size argument. I go pretty far in extension of this. I really do think over time, on the same vein of that like progression of science over time, with how we're going to how we're going to see with how we've seen like Galileo thing with the whole sun around the earth versus earth around the sun thing, are consistent humbling by science. I'm very convinced, or faithful, I guess you could say. I have faith in this, I suppose, that over time, science will force us to be more humble in terms of the beings with which we extend confidence in their level of consciousness to. That makes sense. Only when there are real consequences to one's existence and they comprehend what that means can understanding mean anything. You're now like, so I did a separate video, link in description, where I not only defined understanding in this sense, but I also defined, moving on past that, awareness, and then awareness of others and awareness of self. They're referring to like awareness of self, which I like, self awareness, which I like, what most people are referring to, they say consciousness usually, as opposed to just like sentience, the ability to feel anything, to have a subjective experience. They are referring to self awareness as if it is some prerequisite for understanding. They are, this person, this commenter, is making certain algorithms contingent upon one another in a certain order, which there might be an order. I actually did posit what the order was in that video I mentioned. Again, link in description. But it's not so clear to me that the order they're saying is the correct order. And even so, I have issues with the understanding definition earlier, to where it's like this is just getting out into a different area entirely, in my opinion. AI is not even close to understanding anything. It is humans that understand and then create slash discover the algorithms that get the results they want to do the things they do. It may all be tied up together, but an algorithm formula process does not feel anything in and of itself, or if it does, then so does a rock, a meteor, a raindrop, etc. Yeah, I would agree that those things might. I'm suspicious. I'm very, very suspicious, if not confident they do. In the latter case, then the feeling of such things are so minuscule compared to humans to be essentially zero. But again, I'm not referring to the feeling of understanding. I'm referring to the algorithm that understands. The algorithm understands, you feel yourself carrying out that algorithm. That's what's happening. Anyways, that is it for today. I hope you enjoyed this very long one. Like, subscribe, comment, all the YouTube things in the Discord to discuss. Support me on Patreon or the YouTube join button down below if you have the means to do so and you enjoy me a lot. Um, Hit me up on LinkedIn, follow me on Twitter, all that stuff. YouTube things, like, subscribe, whatever. Yeah, end of video.